Does anyone have any other answers just on nonmetals? Okay.
Non-metal.
Yeah, for covalent, just remember it's only nonmetals. So if they ask you stuff like, oh, how many, like, which is a covalent bond, it's nonmetals. Yeah, ionic is what then? Because if that's not it, then what's ionic? And covalent's only non. Yes, and then do we all agree with that? Yes, okay. Then yeah, that's correct. It's non-metals plus metals. And metallites also count as just like a metal, by the way. Transition metals, obviously, those are metals as well. And then electrons are blank in covalent bonds. What happens to electrons? They're shared. Okay, do we agree with that? Or is there something else you would say? Yes, okay. What about ionic bonds? What happens to electrons in ionic bonds then? Transferred? Do we agree with that? Transferred? Okay. And yeah, that's right. Electrons are shared in covalent bonds and then transferred in ionic. Don't forget that. And then which polyatomic ions are involved in ionic bonds? You can just list examples. Like what type? What kind? Do we know? You can just say like some random ones. OH, O, yes. Carbonate. Any other ones? I just want to make sure you guys can like recognize it. Like when you see it, you know that's a polyatomic ion, and that counts as just an ion in an ionic bond. Sulfate, things like that. Yes, exactly. What about polyatomic ions in covalent bonds? Which polyatomic ions are involved in covalent bonds? Chromate. Okay, H4. Okay, do we have anything else? Anything else about that? Do we agree? That's what's in a covalent bond? Yes. Polyatomic ion, she has a list for you guys to memorize, and I'll show that sheet later. It usually ends in like 8 or it, as you'll see above, or like this hydroxide and stuff. Yes, Amelia? Oh, okay, recognize them. Okay, so actually, do we have? Okay, I just want to say polyatomic ions, you guys are actually wrong. There are no polyatomic ions in covalent bonds. So that was a trick question. Polyatomic ions are ions for a reason. They don't exist in covalent bonds. Yeah, ions only exist in ionic bonds. So don't get that twisted up together. Ions are with ionic bonds. Yeah, that's why when I said, are you sure? Are you sure? Because every time I ask trick questions, kids always think there's like a correct answer, and there isn't. It literally doesn't exist. It's not real. I just want to see what you guys know. But yeah, polyatomic ions are ionic. That's why it says ions. And then, yeah. What about lattice energy? What's lattice energy? Lattice energy. Super negative. Okay. Do we have any other answers to go with that? Do we know what lattice energy is? Do you have any other ideas? Lattice energy? This one's not as important, but I would like for you guys to know just in case. Because I can't tell you exactly what's on there, right? Energy release. Do we have any other guesses? Do we agree? How strong atoms are. Okay. Anyone else? If you don't know, again, you guys can feel free to say I don't know too. Just gives me an idea of what you guys think. Okay, so we have 3 different answers here, which makes me think that you guys are confused because all of these are different. So lattice energy, I'm just going to say it. It's an altering array of cations and anions. So it's going to be positive and negative. It's an array of both. So it's not just all super negative. It's not just like energy release. It's an array of it. And it's not how strong atoms are either. It's just an array of cations and anions. It's pretty simple. I think it was in her notes as well. And then what about the electrostatic potential energy equation? If you've been going to my sessions, we do this every single day. Yeah, Amelia?
In the notes from the textbook, it said specifically that lattice energy is extremely negative.
Yeah, I can see that being a characteristic of lattice energy. I'm talking about the actual definition of it.
Okay.
Yeah, I get what you're saying though. The textbook, the textbook's weird because it's like related to SmartWorks and so we don't like to talk about that too much. And then, so going to electrostatic potential energy equation, what is that? Me too. What about the electrostatic potential energy equation? I would really highly suggest you memorize this. Like, maybe you know that. What is it? Does anyone know? If you've been, like, some of you have gone to my sessions, you know what this is. Do you remember? It's also in the textbook. If you don't know, you can just write, I don't know. If that's okay. 2.31. Okay, what else is there? You don't know? Okay. Does anyone else know? Okay. Okay.
It's
So
the two. Oh yeah, sorry, she typed it. Yeah.
Yeah. Okay. Do we have any other takers? It's just a memorization formula. Or is that it? Okay, so I'm just gonna say, Natalie, you messed up on the upper caret. It's 10 to the negative 19. Yeah, 19. Stephanie's is correct though. 2.31 times 10 to the negative 19. And then what does Q1 and Q2 represent? What is that? Does anyone remember? Atom radii? You could, yeah, but I would say more, it's just the charge. Like, yeah, Akash is right, because he's been going to the sessions, he knows for sure that it's the charge. Like, because you know up here it had this, like, for example, like hydrogen has +1, and then Cl has like negative. So you would do -1, or just like a -1 times +1, which is going to be negative. And then make sure, oh, D, what does D stand for? Does anyone remember what that stands for? Distance, right? So you take that and they give it to you in like some weird with a P. Make sure that when you do this that you convert it to nanometers. So if it gives you like PM or something, for example, like 286 is gonna be 0.286. All right, don't get it like twisted together. So do we all know the equation now? Okay, now I'm talking about the units. For example, distance. If they give it to you in like PM or something, convert it to nanometers, which is like 0.286. You're just converting it, the distance. So you can get the right, the upper caret correctly. Understand? Is that okay? Yeah, it's just the charges. I have an example in a little bit. Yeah. Okay, so polar bonds have a what charge? 10 to the negative 19. Okay, polar bonds have a what charge? What kind of charge do they have? A neutral charge? I'm thinking more of like, if you have two, like here, those two, and one's positive, they're polar bonds, right? What about them? Okay, alright. That's not the exact thing I'm looking for, but you guys are like, you're getting it. It's just like the specific word I'm looking for. No, do we have any? You guys, yeah, that's right. You guys are correct. There's just one specific word I'm looking for. It's unequal. They have an unequal charge. Yeah, it's not balanced, that one. Polar bonds are unequal, which makes non-polar bonds, what? What are non-polar bonds? What's their charge? Do we remember? Because well, yes, exactly. If polar bonds are unequal charge, non-polar bonds have an equal charge, or equal distribution almost, like in a way. You guys get what I'm trying to say? Okay, do you have any other remaining questions? I'm going to do another electrostatic question in a little bit. Okay, we're good? Okay. Okay, so that's the answers. In case you're wondering, please make sure to know this for sure. That's the correct equation. And then keep going. Okay, so now we're doing practice. Which electronegativities are associated with what charges? Or which charges? So polar. What numeric value is associated with that? Polar bonds. Polar covalent. Maybe, yeah. 2 polar, yes. And do we agree with that? 0.2 to, okay, yes, that's correct. 0.24 to 2 is going to be polar. What about nonpolar? What's nonpolar? Yes, 0.4 or anything less is going to equal to nonpolar. What about ionic? So if she ever asks you, like, what's the electronegativity of this, or how do you distinguish certain elements, you'll know how to do that. 2 to infinity, yeah, anything greater than 2. So when comparing ionic radius to atomic radius of the parent atom, what is true about the ions? This one's kind of tricky, I think. Positive and negative. Do we know? Has to do with the atomic and ionic radius, which is based upon the periodic table. So do we know? Do you have an idea? Do you have any guesses? You just write some random stuff. It's okay if you're wrong. Like, I'm not gonna like destroy you if you are. So ion smaller. Okay, it has something, we're doing something more related to just the radius. of certain stuff. Like I want to say cation. I'll say more. Just like generalize it just down to atomic radius and ionic radius. Do we know? Yes. No. I don't know. You can say I don't know if you don't know, because this one's kind of hard. I get it. So no. Okay. So this one, the atomic radius is gonna be bigger for a negative ion, and then atomic radius is gonna be smaller for positive. So it's gonna be inverse. That's it. Like the answer is pretty simple. Like you'll see on the next page when I have answers too. You'll see like atomic radius is just larger for negative, smaller for like positive ions or something. Yeah, I'll have on the next slide. Don't worry. What is the electrostatic potential energy? Yeah, this is the equation that I think Lisa was asking to do an example. This is it. So an electrostatic potential energy of an ionic bond between potassium and fluorine. So if you're giving these two values, how do you find the answer? Given that we just got the formula, how do we solve for this? Because we already have the constant, right? And can someone remind me what that constant is? Find the charges. Okay, well, let's slow down there, Roger. We gotta do some other stuff first. Determine charges and calculate D. Okay, so if we know that, that's it. 2.31 times 10 to the negative 19. What's the charges? Because you guys keep saying find the charge then. What's the charge of potassium and fluorine? And then you guys can just look on your periodic table really fast. Potassium's near the left side. Fluorine's near the other side. Yes, so what's that going to end up being? You're multiplying it. You're not adding it. Yes, it's negative. Yep. You guys aren't adding negative 1 plus 1. It's actually just going to be, you're actually multiplying it. So it's just going to be negative 1. You're multiplying it. Yeah. So it's going to be negative 1 on top. And then I think Roger said something along those lines. Actually, there's an easier way of doing it. So if we do the distance. Okay. Well, we'll get to that in a second. What about the distance? What do you guys think about that? Multiplier. No. With the distance, with the PM that you're getting, you're going to add them together. Yeah, you're not, no, you don't subtract it. You're just adding it. So 189 plus 570. You're adding that. Again, you have to memorize the equation first before you do the math, because you guys are getting like the math wrong. So let's just do that really fast. What's the answer? 759. Okay, do we have any other answers? Because there's no upper caret with that, so your answer is kind of strange. Okay, so when we all do it, what do we get? Okay, I have my answer. What did you guys get? You can just put it in the chat really fast, because Akash got negative 3.04 times 10 to the negative 19th. And remember, you're gonna, yeah, so, same with Akash? Okay, did everyone get the same, or is there someone who got something different? Oh yeah, in essence, the 579, yeah, that's correct for the distance. But we have to convert it as well. So, did everyone get that? Lisa, did you get that? Because I know you asked for an example. Are we all okay? Did we get that same answer? Yes? No? Yeah. The equation is just 2.31 times 10 to the negative 19th times Q1, which is charge of the first one, times Q2, which is charge of the second, all over distance, which is in nanometers. So that's the equation. I would just do it after, it's faster. Just add it together, which you get 759, and then just do 0.759. Okay. Yeah, it's just 0.759, yeah. So, Amelia, you probably multiplied it wrong or something. It's supposed to be negative 19 up there, but your first value is correct. Okay, next one. What's the bond order of C, and then that's 3 little dots right there. So what is that? What's the bond order of that? 3, okay. All right, great. What about O to C? What's the bond order of that? 1, and then 2, is just, again, pretty easy. Yeah, just make sure you don't underestimate easy questions because she gives a lot of freebies of those. So you don't want to be like, oh, that's too easy, I'm not studying it, and then miss the freaking freebie because then you're going to regret it. As bond order increases, bond length what? And what happens to bond energy? Okay, bond length decreases. Okay, and then, okay, decrease. And then what about bond energy? So you guys saying this is decrease, right? This is decrease. What happens to bond energy? Increase, okay. So T said increase. Do we agree with that? It's going to increase then? Yes, okay. Yep, that's correct. If bond order increases, bond length is inversed, so it decreases and bond energy increases. So how do electronegativities of elements change across a row and down a group in the periodic table? Okay, the increase. Do you have any other answers? Up at the top. Okay, do we have anything else? Because I'm going to show the answers on the next slide. So, right, okay. Okay, so let's go to the answers then. So when you go to this, you're decreasing in atomic size. I put that there because I know it's kind of hard because you guys probably think like go left to right or like group and period and stuff like that. It just goes along with atomic size. So a decrease in the atomic size will equal an increase in electronegativity. So that's how you would know how to know that. And make sure you really do know electronegativities because her test is pretty spread out evenly, like over every single section. There's not one thing, I think, when I looked at the whole test, I didn't see one thing that was shown more than the other. Like it was all pretty even. So make sure you know every single section. 3 to last. This one? Oh, or this one. The electrostatic. A number of bonds. Yeah, you're just counting the numbers. So this right here has 3 because there's 3 bonds in between. Okay. C to O, that's just 1. So you're just counting those sticks in between. For number 3, okay, I don't know why I put 5 there. It's supposed to be 3.4. Anywho, but that you're just plugging it into the equation that we just did, the 2.31 times 10 to the negative 9, and then it's just going to be, for the charge, it's just negative 1 over 0.759, and then just multiply times that constant. No, you're right. I don't know why the wrong answer is there, because even when I did, I got that too, so I don't know why that's on crack. Anywho, do we have any other questions? Can I write out 3? Do you still need that out, or are you good? How do you find the charge of an atom? On here, you just look up above. Like, metals are usually positive, non-metals are usually negative. Are we good? Okay. Alright, next then, because we have a lot to do. Name the polyatomic ion. These should be memorized really fast. If you went to my old SI sessions, this should go by really, really fast. Just to know it. Because you'll see some of these probably. Yes, that's correct. What about acetate? This one's a little longer, but you might see it. Okay. Amelia, I think Amelia, you're like confused on something. Okay, Eden and T have their answers. Do we have anyone else that wants to give it a try? I think T, you put in an extra H in there, an extra hydrogen. 2O2H something. Okay, that's confusing to read. Actually, Eden's correct. Yes, Amelia?
I've seen it both ways for acetate, so it's the same thing, I just combine them.
Oh, okay. I guess I just never see it like that, so that's interesting. I just like it the other way, usually, because that's the one I usually see on tests. So you'll be able to recognize it faster.
Yeah, no, I know them both. Sorry, that was just the first one I typed.
No, you're good, it's fine. Okay, do we have any remaining questions on that? Okay, probably not. Okay, chlorate. What's chlorate? Chlorate. Okay. Do we have any other answers? Okay, well, let's go to nitrate. Nitrate and nitrate. What are those?
NO2 minus,
2.
NO3 minus.
Okay, and then, yep, that's right. Just make sure you know that nitrate's 2 and then nitrate's 3 on the bottom of the NO. You know, and then what about hydroxide? OH, yep. And then phosphate.
OH.
Oh,
OH minus.
yeah,
So
phosphate.
hydro-
Very good. What about sulfate?
P
What's sulfate?
O.
All right.
P O something.
Okay. Any other answers for sulfate? Because we only have one. Just put something out there. Nope. Okay, well, actually, it's supposed to be 2 plus. I'm pretty sure. Not 2 minus.
PO4,
And then
3
for
minus.
chlorate, I actually had 2,
PO4
so
minus.
it's definitely iffy. But yeah, this part's just memorization. I wouldn't worry about it too much on the test, but make sure you just know like the ones like you see here. Or, like, did you never put anything I think too crazy on the test? So I think you'll be okay. So that's that.
SO4.
Okay, yeah, just make sure that's plus. It's not negative. And then we're good on that, I think. And then she wrote this, so she said you will want to memorize the following polyatomic ions. You need to know the name, formula, and charge. So she put all of these out here. I don't think you need to know all of these, but I think just the fact that it's like a test and you know, you would have to know. So again, just like lightly memorize them. I wouldn't say like you have to go in really, really deep and memorize like sulfate.
2 minus because sulfite is also 2 minus. So
Oh dang. Oh, okay. Guess it's negative then. My bad. Then where did I get that from? Okay, then I guess that one's negative then. My bad. Okay. Anything else? I have my own special like periodic table. You guys have like I think a plain one, so you don't have the same stuff I have because mine's more helpful. But yeah, when I looked up sulfate, I get like 2 different. Whatever, it's fine. Just use this one because this is the one she gave you. Use this one then. Okay, so we're good on that. Polyatomic ions. This is just memorization, pretty much. Yes. Okay, I'm just gonna assume that's alright. Okay, rules for binary molecular, which is covalent, ionic, and then transition metals. What symbols are used to indicate charge on transition metals too? So rules for binary molecular. What are the rules for that? Like, what's the first thing you do? You have 2 elements here. What do you do? Okay, how do you name them? How do we name binary molecular compounds? What do we do with them? What do we add to them? You don't know? Okay, does anyone else know? Prefixes, yes, exactly. You add prefixes to just one, both, like what do you add? Element, okay, IED, yes. Anything else? Yes, you add prefixes to both, and you put IED at the end of the second element. And then, is there any exceptions? Is there anything else that we need to know about it? Binary molecular?
If there is just one charge.
Yes, you don't add mono on the first. Yes, exactly. There's no mono on the first. If it has like just nitrogen O2 or something, you just put nitrogen. Yes, and then transitions never have prefix. Yep, exactly. And then what about ionic? Is that the same too? Yep. Ionic. Yes. No transitions. Yep, exactly. And then what symbols are used to indicate transition metals? So you can recognize it really fast.
Poly.
Like what Roman numerals, yes, exactly. So what prefixes are used in binary molecular and ionic? But we know there's no ionic. That's just a trick question, but you guys obviously got past that already. So what prefixes are used in binary molecular? Mono, okay. So that's 1, 2, tetra. And make sure you put the thing with it. Like what number goes with that? Di is 2, tetra is 4. Yep. Binary molecular is covalent. 3 is tri. Okay, what about 5? What's 5?
Penta.
Penta. Okay, 6.
Hexa.
What's 6 then? Hexa. Okay, 7.
Hepta.
Hepta. Okay, octa, nona, deca. Yes, that's correct. And then 8 is just octa, 9, nona, deca is 10. Okay, elements have in the same group have what? What do they all have the same thing of? In the same what? Also. Well, this goes with Lewis dot structures. Valence electrons, which means what about their Lewis structures? What is that synonymous with? Valence electrons with Lewis dot structures. Yes, the same number of dots. You want to have, so when you calculate valence electrons, when you do the Lewis structure, you should have exactly the same amount. And that's either by, you can add extra lone pairs or you can do double bonding, things like that, but it should have the same amount. And then if an element has a plus, what happens to the overall valence electron? And then same with a negative. Less E, more E. Yep, exactly. Do we agree with that? I don't know why the answer was there, but yes, you have, I think you guys already know that though. Like it has a plus on top, you subtract a valence electron. If it's a minus, you add an electron. And then again, that becomes your new valence electrons for your Lewis dot. And then how do you know the order of molecules when drawing Lewis structures? What's the trend? So you have like HCO, how do you know what goes in the middle or like that? Electronegativity, what about it? Okay, Akash said less electronegative in the middle. Okay, yes, exactly. The least electronegative will be in the middle, except when it comes like hydrogen, for example. Hydrogen will rarely ever be in the middle because it can only have what? What's the thing about hydrogen? Yes, one bond. And it can only hold how many electrons? Two. It's two actually, yeah, because if it's one bond, I think you mean it has two. So it can only hold two, which makes it one of the few atoms or elements where it can have an incomplete octet because it doesn't need it. Does anyone know the other element? Hydrogen and what? What's the other element? Be. Okay, does anyone have anything else? N. Okay. What's the other element that you don't need to have a complete octet? Period and below. Okay, I have a question on that later. We'll get to it because you guys are kind of lost. Okay, let's just keep going then. So this is just the rules for all of them. Beyond, actually. Yeah, but this is just the rules. I hope you guys know that. It's just naming, which you guys should know. She puts quite a bit on there. Again, it's spread out pretty evenly, so just make sure you know that. E and Al. I believe it's supposed to be B and H. We'll get to it. But yeah, here's the prefixes. We already went through that. Again, just memorization, pretty fast, pretty easy. Yeah, this is the last slide as well. I had to chop it up because it was like so much. But yeah. After that, okay, let's practice writing and naming compounds. What's P negative 3? Or P3 negative? Like it's kind of hard to write on here, but what is that? Does anyone remember? P3, like, oh wait, that's a B. P, like, 3, that. What is that? Yeah, I can't really do an uppercut very much on here. I kind of just like space it out. What is that called? Phosphorus? Well, it's not just a P, so there's something to it. Because you can't just have a regular element, because if it was just P, then it would just be that. So what is that actually? Because not phosphide, triphosphate. Well, this isn't, it's not on the front, so it's not on the bottom. Actually, it's going to be phosphide. It's going to be phosphide, and it ends in IDE. So I think Amelia got that one right. And then lead oxide, what's that going to be? Well, it's just for this case. I'm not sure why. It just is. I don't think you guys are going to have on something like that on the exam, so you don't have to worry. That's just an example of how to name them. Lead. Okay, we have PbO2. Any other takers? And how do we get that answer? Do we know? Is there someone else that wants to switch charges? Okay. What about the 4 here? What does that mean? Like, what do we do with that? Like, what do we do with the Roman numeral? What does that stand for? Yes, it's the charge that goes with lead, by the way. Because I said this at another session, and I think some people didn't know that. But yeah, the Roman numeral goes with the first transition metal you have. That's going to be 4, oxygen's -2, and then yes, you do switch it, so it's going to be PbO2. What about calcium and selenium? What kind of bond is that? Calcium and selenium. It's on the periodic table. Covalent, okay. Does anyone have anything else? Ionic? Oh yeah. Yes, it's actually ionic. Because if you look, I don't know, maybe you guessed, but calcium's clearly, it's a metal, so it's going to be +2. So because that's +2 and then selenium's -2. You switch it, you simplify, it's just CaSe. What about PO4, 3 negative? What is that? Phosphates? Phosphates? Okay, very nice. Yes, that one's just a polyatomic ion. I just wanted to see your memorization. What about magnesium OH2? What's that gonna be? Magnesium hydroxide? Yes, exactly. Right. And that's just a polyatomic ion. And remember, that's just one up there. Magnesium, as you look, is +2, so you switch and you get magnesium hydroxide because of the H. What about chromium 3 oxide? Okay. All right. And then do we agree with that? Because that's correct, yeah. It's pretty easy, I think, because this is -2, so you just cross. What about N2Se3? And that's selenium, and that's nitrogen. So what's the name for that? Do we remember all that? What is that? Chromium 3 oxide, or I mean N2Se3. Do you remember what that is? The -2 is just the charge. Like if you look on the periodic table where you see oxygen is, it's the charge of -2, and that's just memorization. Like you just have to know oxygen's -2. It's just the charge. And then yes, you guys are right, and because that is a binary molecular covalent, so they're both going to have their own prefixes. What about BrO2? What do we get on that? Dioxide. Okay. Do we have any other answers? Okay. And we all agree on this then? Bromide dioxide? Yes. Okay. Very nice. And then, yes, you guys are all correct. So, do you have any questions on this? We're all good? Because I think this is pretty simple. Like, if you knew the rules before, this should be pretty easy. Yeah. Okay. Good. 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 Okay. Let's just keep going then. Okay. How do you determine when a bond is weak or strong? Do you go name acids? I'm not really sure how to do that. I would definitely highly here. I'm gonna write that right there. Know how to name acids. I don't know how they did it in the book, but maybe we're getting chemistry too. I have no idea where she got that because I went in the textbook and there was no remnants of how to name acids, but you definitely do need to know that. So, like name, there was. Oh, well, I didn't see it. It was there. Well, then definitely go over that. You're gonna need it. Single bond is stronger, right? Actually, you're thinking about length. Length is like that. How do you determine if a bond is weak or strong? Stronger, more bonds. Yes, exactly. If you have a 3, it's going to be way stronger than if you have 1. If you're doing length, it's going to be the opposite. 1 is going to be way stronger than 3. It's just inverse. What about resonance? What is a resonance structure?
Different types of that one.
Does anyone remember how to explain that? Picture you have? Okay. Oh, another form of illusion. It's like flipped. Okay. Alright. Okay, so I want you guys to have the actual formal like definition that could be said. It's the average. Like once you have the electron like structure, you want to know that it's the average. Just remember that, the average of the Lewis structures. The electrostatic structure is going to be the average of the Lewis structures. Average. Remember that. Just in case. Like, average. Okay. How do you calculate bond order? What do you mean? So if there's a single or double bond, it's 4 per bond. Average the bonds. Actually, like that. Okay, what I just said, I'm just saying that as a definition, just in case like there's conceptual that comes up, you would know that. But if you have like all these other answers above are also correct. Like if you just know the general idea of it, it's fine. But just remember that definition, too. Remember both. So know what it is, but remember that definition as well. How do you calculate bond order? Single versus triple bond? Yeah, if there's, the more bonds you have, the stronger the bond will be. So, because this has 3, it's going to be stronger. And that's when determining the energy, like the bond order. But if you have bond length, the less lines you have, the less bond pairs you have, it's going to be stronger. So 1 bond is going to be stronger than 3 bonds because it's shorter. 3 bonds is going to be more, but it's going to be shorter. Okay, what about, calculate bond order. How do we do that? Does anyone remember how to calculate bond order? I'm not sure you'll need it on the test, but I would recommend knowing it. Just know that, like, don't take it too seriously. Just know average. Like, the electrostatic structure is the average. That's it. That's all I'm saying for this. If you have your own, like, resonance structure definition, that's fine as well. And then calculate bond order. I don't think anyone really knows it, so I'm just gonna say it's the total bonding pairs, which is just these. And then you're just gonna subtract it by the number of atoms bonded to the central atom. So what's the bond order of CO3 and 2 negative of this?
1, 2, 3, 4.
What's the bond order?
So 1, 2, 3, 4.
1.33. Okay, do we agree with that? And how did you get that?
Wait, what are
Does anyone know?
what are we
Yeah, okay. Yep, it's 4 divided by 3 because we have 1, 2, 3, 4 bond pairs divided by, yeah, all divided by 4. Actually, it's going to be 4 divided by 3 because of 1, 2, 3, 4 bond pairs divided by all the zeros, all the oxygens, which is 3. So that's going to be 1.333. And then what type of bond is H2? Do we know what type of bond that is? Can you do? Nope.
Wait,
Okay, does anyone else know? Like, what's H2? Polar covalent. Okay. Okay. Right, do we have any other answers, any other guesses of what that could be? No? Okay. It's actually non-polar, so no one was correct. I think you'll probably get into this probably more next. But it's going to be non-polar because anything that has like N2, H2, like a double, that's definitely non-polar. Bond order again. You're just counting the bonds. Bond order. So this is 3, which means it's bigger than 1. That's how you do it. That's it. And then for if you're talking about the bond order question, the 4, 4. Okay, you have a double bond here. That's 2. You have 1 here. That's 1. 1. So you're gonna do 2 plus 1 plus 1, which equals the 4. And then you have 3 oxygens here, and that's 3 bonded to the central, so that's why it's 3. Yeah. Okay, I think I had some questions. Yes. Yes, Summer, that's correct. Oh, yeah. Okay, yep. I don't think you guys are going to need to calculate it, maybe. But I didn't look at every single question, so I just want to put that there just in case. The number 3 on the bottom was pretty easy. Which of the following bonds is not possible? D? D? Okay. Yep, that's correct. And why is it D?
Because hydrogen can never have.
I think we just went over that a while ago. 2 bonds to H. Why is that not possible? What's the explanation?
Hydrogen cannot have.
Has 1 what?
They have 1.
Yes, it can only hold 2.
Yeah.
Exactly, duet, exactly. Yep, each can only hold 1. 1 single bond pair, that's it. Or just 2 electrons. Okay, are we okay on this side? Resonance and strengths and lengths of covalent bonds, yep. Okay. And those are the answers. And then, okay, draw the resonance structures of HNO3. Okay, wait, go back. Okay. These are the answers. If you have any questions, you just tell me. Or you can email me. There's something you need to know. Okay, so draw the resonance structures of HNO3. What's the central atom? Or what? Because it's kind of an uneven amount. What's going to be like N? Yes, exactly. So we have that. So actually, let me erase that because I need more room. Okay, so if N's going to be in the middle, what goes around it?
H O.
H, no, okay. So what goes on this side then? The H or the O? H. Anyone else have any guesses? O. Yeah, it's going to be the O because if you have an H, you're going to connect that on the outside, right? Because H can only hold 2. You want that on the outside. It'll make more sense that way. And then on here, you can have O. And then on top, we can have another O. So what should we do next? Because we need an octet, right? What do we do? Is there anything that you would change to this structure? You could make it this way. You could go, but you would have to do it on the right side. Because you want H to end on the very end. Count valence electrons. Okay, so when you count valence electrons, you could. I'm just doing it this way. Like, there's multiple ways you can make it look, but this is the way like I would do it. Okay, so when you do this, what goes on the outside here then? Oxygen. How many will go out there? Do we know? Once we do that, once we do the valence electrons and everything, because we have 24 valence electrons, right? Because I'm pretty sure we all know how to do that. So what goes on the outside of oxygen here? How many valence electrons?
6.
6. It's going to be 6, right? Because you need an octet. So you're going to do 6. And I'm just going to do this line to represent that 6. And then what do we do next? Is there anything else? Because hydrogen's full, right? Because we have 2. So what about the other oxygen? That's 6 to the other one. Okay, 6 on the other. Is there something else we could do instead of adding 6 up here? Because if we add 6 here and then we add 4 more here, nitrogen is what? It's not full. Create a double bond exactly. Because if you just put 6 there and you put 4 in the other, and it's not complete, so therefore you don't even have a Lewis structure. So you'll put 2 more on here, and then here we put 2. And then exactly, that's how we do that. And what's the other resonance structure? How would we draw that? What would be the other bonds instead? What would we do instead?
Can we share from this side?
Yes, exactly. So this one's going to have 2 and this one's going to have 1. And then you have 2 resonance structures. Make sure that when you do this, you know when you calculate or you find your resonance structures, have the correct amount of resonance structures, just in case they might ask, how many resonance structures does this have? What do you notice about the NO bond lengths? Shorter, longer, what do you notice regarding those 2 things? Weaker for which one? The single or the double bond? Single bonds, yes. Well, it does bond energy. If you're looking at bond lengths, what's longer? Single. Yeah, exactly, single. I don't know if that's response to my question, but yeah, bond lengths, this is gonna be stronger or longer, really. If you're talking about energy, the double bond's stronger. It's just the opposite, really. And then for number 10, it's just a multiple choice. Choose the incorrect statement. A. Okay, do we have anything else? Okay, A. Any other answers? Confusion? Okay, A. Alright, yep, that's correct, A. And why is that incorrect? Can someone explain, how'd you get A then? Why is that one incorrect? 4 electrons are in double bonds. Yes, exactly. For this one, when I first read it, you kind of get confused, or you might not read it properly, especially as I'm saying time management, because this is a really easy question, I think. But if you're focused doing this resonance structure and you're taking 8 years, then when you get to this question, you're just gonna gloss through it and you're just gonna choose B, or you're gonna choose some other dumb answer which is incorrect. So it's gonna be A, right? Because this is electrons. It doesn't say electron pairs, just electrons, which is just a single bond, not a double. Okay, are we good on this? Resonance structures is okay? Yes, okay, very good. Let's keep going. And those are the answers. Again, this is how I would draw it. So, yep, and then you're just switching up the bond stuff. Diatomic molecule is just one that has 2 atoms. You have H2 or something, it's just 2. That's pretty much it. Okay, we're good on this side then? Alright. So, which elements can have expanded octets? Do we know? Okay, period 3 and below, period 3 and on. 3. Okay, very good. You guys know that it's at least period 3. Oddly enough, I feel like it is below, but that's the thing. On Dr. Kelly's notes, she puts period 3 and beyond. So I don't know if she made an error, but she wrote that. So that's very weird. Octets, yeah, it's just having 8 electrons in a element. So if you have N, you need to have at least 8. That's pretty much it. Just having that. Yeah, that's what an octet is. And when you do, it should be 2, 8, and then 8 again. And then which elements can have an incomplete? So it's period 3 and below. I believe so, yes. And so what about which elements can have incomplete? So it's an H, E, B. Any other takers or answers? AL. Alright. So when I look at Dr. Kelly's notes, and I'm going off of her notes because she makes the questions, so I don't want to mess with that. For her, she said only boron and hydrogen. So I suppose those are the ones you need to know for sure. Because she didn't mention aluminum. I'm pretty sure, because that's the thing, when I took Chem 1211, I'm pretty sure there was like multiple things you can do. Yeah, she said, yeah, I remember, like BE you can, I saw in the textbook before, but on her notes, she doesn't put that. And I don't want to mess with what she wrote because she writes the test. So just have these in mind for sure. You can have the other ones as well, like BE and like aluminum and stuff, but just make sure you know for sure that boron and hydrogen can have incomplete octets. Some people were saying aluminum can have an incomplete octet as well. And then how do you calculate formal charge? What's the equation? Do we remember? What's the equation for formal charge? Minus lone pairs plus lines. Okay, do we have anyone else? Because Akash said that. Does anyone have anything else they would say? Minus one, minus bonds, minus, okay, plus lines. Okay, alright, that's interesting. Okay, so the way I would write it more of, because the way you guys are writing, I feel like we have the same answer, it's just you guys are writing it differently, where it's valence electrons minus lone pairs, or like your bonding atoms or electrons, and then you're going to subtract your or your lone pairs, really. This is supposed to be lone pairs, I believe. Lone pairs, and then you have your bonding electrons divided by 2. So that's your formal charge. That's just memorization. So valence electrons minus lone pairs, which you count individually, by the way, and then it's minus your bonding electrons divided by 2. So you have 10 divided by 2, that's 5. And then you can always just multiply it times 0.5 as well. And then blank formal charge, counted each. Yeah. Well, bonding electrons, because usually it's in like this. Because when this is 8, you do 8 divided by 2. For the lone pairs, it's more like if you have 2, you kind of just 2, really. And then, okay, so let's go on to the next one then. Blank formal charge is better than blank formal charges. This one's kind of empty, so you can't fill it in, but no, it's kind of like bigger, smaller, like that. Okay, yeah, smaller, that's what I'm looking for, really. Yep, you guys all have like different variations, but yep, smaller formal charges is better than what? What formal charges? Higher, bigger, larger, yes, exactly. Anything larger, because if you have a larger formal charge, it's not as accurate as having a 0, because if it's 0, that means it's the most ideal, it's what you want, it's the best Lewis structure, best resonance structure. Not negative. If it's negative, that's also not good. You want 0. And that's the next question, which an ideal Lewis structure has what? Overall formal charge, that is charge of the molecule. I would probably, formal charge, I would just try to because if you have a molecule and you have it all written out, I would say you probably want to find the formal charge before anything, instead of just saying, oh, it's the charge of the molecule. Oh yeah, well that's true too. But I would just suggest writing out the formal charge. 0 charge, yes, an ideal Lewis structure is a 0. You don't want negatives. If it's positive versus negative, they're both equally just as bad. You want 0. Because that's supposed to be perfect, there's no flaws in it. And that's probably the most correct resonance structure or electrostatic structure. Negative formal charge should be on the most. Yes, exactly. Yes, exactly. So it will be on the highest or the most electronegative atom. Okay, do we have any questions on this part? No, okay, good. Atom. Whatever. I would say negative formal charge is usually on the most electronegative atom. So yeah, again, like the test isn't that bad. Like if you did well on the first test, I would say you'd probably do well on the second test because I think they're probably, in my opinion, I think they're the same difficulty. Like I don't think one's like way harder than the other one. Like they both have equal like. Oh, well, don't say that. Don't say that. We're gonna be fine, okay? There's a study that said that if you say you're gonna do well on something, you're more likely to do well than if you say you'll do worse. Like, oh, I'm gonna do terrible, you're more likely to do terrible. But if you say, oh, I'm gonna do well, you have a better chance of doing well. It's like a psychology thing. Feel better. Yes, exactly. Just, yeah, exactly. Manifestation. Just make sure, don't, like, time management. Don't spend too long on a Lewis structure if you can't find it. If you can't find the answer, do your best, like just choose one that you think is it, write down what that question is and come back to it later. Because I remember the exam too, a lot of kids, they spent way too long on Lewis structures and then they group me after the test. They were like, oh my god, I didn't have enough time. And I was like, yeah, because you probably dwelled on like a Lewis structure when you probably shouldn't have. And then they missed all like the freebies because they spent too long doing like question number 10 when there's like 30 questions. So just make sure you know time management. I didn't have Dr. Kelly, I had Dr. Jones, and our tests were, we had no extra credit, no extra credit. We didn't have, like, he didn't do sessions, we didn't have an SI, it was asynchronous, so we didn't have, like, any, I taught it to myself, and he never dropped a test either. He never replaced the test, he never. Okay, how many of you guys are taking Chem 1212 again? Okay, so if you're taking it, a lot of Gen Chem 1 isn't really included in Gen Chem 2, if I'm being completely honest. Like, a lot of it's, like, you might use intermolecular forces, definitely, but you'll learn that later, you guys haven't gone into it. But a lot of it's completely different. And then for professor-wise, all of them have kind of bad professors, if I'm being completely honest. But we'll get to that at the end. Okay, so that's what we have. And then these are the last two we have, and this is just, I have 4 multiple choice questions. So for this one, choose the best Lewis structure for ICL5. E. Okay, yeah. Some of you, I think, took this before I put this somewhere else, because I put this out a while ago, or yesterday, I think. Okay, so we have B. Does anyone else have any other answers on the homework? Oh, wait, you guys had this on the homework? Dang. Oh, dang it. I didn't know that because I don't do the homework. But yeah, it is B. I guess you guys already knew that. And how do we know it's B? Because we already know, because you guys had on the homework. How'd you guys get B? How do you know it's B? What makes it B? How do you know? Okay, for this, what I did personally is I did formal charge. And when you calculate formal charge on this, you get 0. Yeah, exactly. Summer's completely right. Yep, it has the lowest formal charge. And again, like that's why I said you have to know that equation really fast so that when you do all 5 options, you can just do the math. You have to be very organized. I think most kids use like a bunch of sheets of paper and like, so try to be organized when you do it, or else you're gonna lose track and you're gonna go back and forth and stuff. So number 4, which of the following statements is true considering the Lewis structure formula that minimizes formal charge on the sulfate ion SO3 2 negative? So when we do that, this one's kind of long, so I don't know if we can get through it because it's so long. But does anyone know the answer? Yes, all multiple choice. D, okay. And then how do you guys get that answer? Can you guys explain? Because I don't think we have time to draw it all out and stuff. It would take too long. It was on the homework. Dang, really? Okay, but how'd you get it? Yes, exactly. So when you calculate and you draw out this molecule, I had done it earlier, but we don't have enough time. But when you draw it out, you calculate S, you get 0, and then because you have different resonance structures with the O's that are attached to it, you'll see that there's one with like 6 or like 2 or something with different number of valence electrons according to the overall valence electron. You can either get 1, or the other one you'll get is 0, or you'll get -1 for that. So are we okay on this? Because the answer is D. Are we all good? You just had this in the homework, so I imagine, yeah. Okay, so those are the answers. And then these are the last two. Draw the Lewis dot structure for CO, and then what's the formal charge on the oxygen?
6.
So, how do we do this? What's the answer? You have C
Double bond
to
between
O. What's the formal charge on the oxygen? Do we know? Because what's the valence electrons on this? We have 10, right? 10 valence electrons, because that's 6 and that's 4. So that's separate, by the way. It's separate. So that's 4 and that's 6, so that equals 10. How do we get 10? Okay, got D. So if we want 10, what do we do to this structure? Because to get the answer to this, you have to do the structure first. Sorry, B. Okay. Does anyone know how many bonds go in between C and O? How many bonds is that? 1. If you want 10, you can't have, yeah, you need 3. Actually, you need 3.
Yeah,
You need a triple bond, yeah. You would need 3 for this because you need 10.
yeah,
That's 2, 4, 6, 7, 8, 9, 10. And you could do like 2 and stuff, but it's not the most efficient way. You want the most efficient, like the best way. This is the way to do it. And when you do this and you calculate the formal charge, the answer is B. You get B.
1, 2, 3.
So are we okay on that?
-1.
Okay, so what's the best Lewis structure for OCl2? And then it's the same one as I believe the first one I just gave. It's just a different option.
1.
So you guys can just practice it again to have more and more practice. Because you get questions, like I guarantee you'll get questions like this on the test. So what do we get? What's the best way? For OCl, what do we get? E, okay. Connor said E. Did we all agree, disagree? Agree, okay, yep. That's completely right. And I think the easiest way to see this is because Cl is a part of the like halogens. Halogens rarely ever have a double bond with something. So as you can tell, this one also only has just 2. Also, the formal charge is 0, so that's how you would know for sure. But yeah, that's all you have to do. Are we okay on that? We're good? Yes? No? Okay, do you guys feel prepared? Because if you went through this PowerPoint and you knew all the answers and you understand it, you'll do better on your test. Because some of the stuff, like, you will see it again for sure. So, yeah, again, the test, just make sure you know for sure, like, valence electrons, how to identify ionic, covalent. Sure, yeah. And then, good. And then, what else should you know? Electronegativities. Make sure you know how to do this. Yeah, make sure you know how to do electronegativities as well, how to calculate it, which elements you see on here, like how would you tell which one's more electronegative versus less electronegative, Lewis structures, how to draw them, you'll need that for sure, to answer questions relating to like formal charge and stuff like that. Exceptions you'll need to know as well. Those are just like off the top of my head, like questions I remember for sure. You should probably like look over those chapters because they relate to like what 4.8, 4.1, all this other stuff. So yep, those are the answers. And then I should probably go over this some other time, but SI applications are open, so if you feel like you're gonna make an A in this course, like I'm sure some of you like are really good at chemistry and you're doing well. If that's the case, you should apply to be an SI. And then you just do what I do, where you have sessions and you have meetings and stuff like that. And so if you want, you can apply now. Their interviews start like after spring break. So yeah, I think can't really answer that. it's a good amount, like of everything that you've learned in chapter 4, it's a good amount of everything. Yeah, I'm gonna send out I'll send out the flyer for this because SI is really not that bad and it's a good way to like make money on the side, I think. So that's it. If you guys can leave, make sure you sign the attendance sheet before you leave. Do you guys have that? Or did I send it again? Did everyone sign that? Yep, here, I'll put it down. Yeah, I had a feeling. Just make sure you sign that so the attendance link. And that's pretty much it. That's all. And I'll just stay back, and if you have any questions or you need like advice with like Chem 1212, yeah, I'll send it to everyone who came here. Yeah, I'll do it. Yeah, that's pretty much it. Oh yeah, those are the Chem 1212 professors. I have Stalin's right now. A lot of kids are angry with him, so your choice. Yeah, Liu Kang. Yeah, which would you recommend? Stalin's is. They're all kind of weird. I wouldn't say any of them are great. Stalin's is kind of like, I think his tests are like medium. He has 20 questions, some bonus sometimes. He gives a lot of bonus points, but his smart works, he has them all due at the same time, like on the same day. So you have to be careful with what you pick and choose. Aside for Chem, I hate Chem 1212. I mean, I'm doing fine in it. I just don't like it. I can SI for Calc because I'm at 100 in Calc, but I don't like Calc, so that's why I don't SI for it because I hate it. I hate a lot of things. I might SI for bio next year too, because that's easy. If you're doing Calc, take Dr. Babuk Moez. So do I. I don't hate. It's tough. Of course. Babuk Moez. How do I spell that? I can't. I wish I knew. It's like Babuk Moazzi. Something of the sort, like that looks like that. You can search up that first name, it should work. Okay. Yeah, that's how you spell it. I never know how to do it. Yeah, but he gives everyone like, I think he gives like 12 bonus points. It's like the end of your grade class. So you can make like, an 89 or, so yeah, that's it. Yeah, of course. If you guys have any remaining questions, I'll just stay here. Stephanie, I'm not really sure. You'd have to ask her that. You can try asking her that during your set 5:30 review because I'm not sure about that.
Okay.
I don't know. She doesn't I think teachers are assigned what courses within their department.